So this is just a further discussion on how I quickly generated the Racemic product here. And I'm going to show you both ways here. If your orgo test happens to be a fill in the blank, or if it has to be multiple choice, I want to show you how to handle both situations. Let's look at the fill in the blank type method first. So again, let's establish here that, remember, we've already decided that this carbon is going to get the Br, and in doing so, he's going to become chiral. So then you would focus on, well, what's going to be still connected to him? He's still going to have at least one of the hydrogens. He's still going to have this methyl right here. And of course, he's still going to have this ethyl over here. So you would start out by drawing that carbon right there. And to make your life easy, stick the fourth priority group in the back. If we look at our molecule, notice out of the methyl, ethyl, and hydrogen, of course, the hydrogen would be the fourth priority. So at this point, you could put on any substituent you want. Like for instance, I know that I'm going to add a Br to this carbon. So boom, right there, I'm just going to add the Br. And I could put it anywhere, but I'm going to choose to put him right here. And remember, setting priorities, we'd have to know that the Br is going to be priority 1 for that carbon. Which means this to us. Remember, let's say we're trying to draw the R representation first. So that means if that Br is priority 1, the sequence has to turn from here to here, which means we have to put our 2 priority group right here. Well, looking at our actual molecule here, who would be second priority? It's down to either the methyl or the ethyl. And of course, it's the ethyl that would have a higher priority than the methyl, so the ethyl would be priority 2. And then lastly here, putting our priority 3, he would have to go in this direction. So we should put our third priority group right here. And the only one left is the methyl, so he would have to be the third priority. And notice in doing that, we get our sequence turn with 4 in the back and our substituents turning in an R direction. So that's how I quickly did that. Now, if you wanted to generate the S, you can do the same exact thing, but obviously make sure the substituents turn in an S direction. Or you could do something even easier here, is just simply draw the R and then draw the R's mirror image. The mirror image of that molecule will look exactly like this. And you can be guaranteed that, remember, the mirror image of R is S, so at that point you'd be done. So that's how you would handle a fill-in-the-blank type test. If it was a multiple choice test, it's actually even easier. Think about it. When a multiple choice test, the answers are right there in front of you. A, B, C, and D, let's say. All you're doing is going through those answer choices, and you're trying to find a carbon that has 4 groups attached to it. That is an H, a methyl, an ethyl, and a Br, and you're determining whether he's R or S. If you happen to find a molecule like that that's R, then you're going to pick that answer. But you're also going to be looking for the other product, the S. So the correct answer choice is going to have 2 molecules in it, which means if you see an answer choice that only has 1 molecule, you could definitely get rid of that. So that's the advantage of the multiple choice test, is that we don't have to draw them. They're already drawn for us. We're just picking them out of the lineup.